Dante Certification Level 1, 2nd Edition. Dante is standard networking. The first thing to remember about Dante is that it is standards-based. You can use commercial, off-the-shelf equipment. No special hardware, no special firmware, and no special settings required. And that means you can use networking equipment that you're already familiar with from your favorite brands. If you're putting Dante equipment into an existing facility, you can have confidence that Dante will run on the existing networking equipment. When discussing network switches, you'll hear people talk about managed and unmanaged switches. And these will come in all shapes and sizes. Dante can use them all. An unmanaged switch is designed to create a wide open network. They deliver a positive, out-of-the-box experience. Just plug your devices in and everything works. This is often done for small networks that are only carrying Dante traffic. By contrast, a managed switch might allow for traffic to be separated, optimized, and even restricted from certain areas. Managed switches are helpful when dealing with larger deployments or when integrating with other systems on a converged network. If you continue on into Dante Certifications Level 2 and 3, there you will learn about managed switches and how they can help. Personally, I suggest everybody continue on at least until Level 2. And if you've never worked with a managed switch before, you might be happy to know that we have written a tutorial that will lead you through a particular managed switch. So this guide does not deliver a certified switch configuration. I think that there are artistic choices in designing a network, just like there are artistic choices in designing a sound system or a video deployment. However, this guide will take the lessons that you've learned in Levels 2 and 3 and offer a hands-on experience so you get that first-hand knowledge with the technology. If you've never worked with a managed switch before, I highly suggest checking that out. So, Dante can work on both managed and unmanaged switches just fine. The engineers at Audinate took great care in designing Dante so that it will optimize your performance when you do not have control over the network switches. But if you can optimize the traffic, Dante also provides the hooks to take advantage of that. Now, when you're looking for a network switch, there are a few things that are helpful to look for. First, we recommend a switch that is 1 gigabit or faster. Now, many of our devices will have a 1 gigabit port on them strictly for bandwidth reasons, right? We can get more channels down that path. However, higher port speed also means more accurate clocking. Not only do you have 10 times the bandwidth, you have 10 times the transmission opportunities, and that means more accurate clocking. Let's suppose I put some tick marks for every chance a 100 megabit frame begins. Below it, I'll put the alignment for 1 gigabit. When a packet arrives for transmission, there's a significant difference in how long it has to wait until that gets transmitted again. And in fact, the variation for a 100 megabit port will be greater than the variation in a 1 gigabit link. It all depends on when the packet shows up. So in our experience, a 100 megabit port is fine for a low bandwidth endpoint. But for the clock leader, especially as the network increases in size, the benefit of the gigabit port will become apparent. Another thing to look for is Power over Ethernet, or PoE. PoE allows us to deliver power to your device straight over the Ethernet cable. It's convenient, and it simplifies your cable management. You can see there are a few different standards that have evolved over the years, delivering more and more power to the end device. Now, when someone asks for PoE++, or they ask for the standard number 802.3bt, it's worth asking whether they mean the 60-watt or 100-watt version so you can budget for power accordingly. When a device calls for PoE, it doesn't necessarily pull all of the power offered by the standard. It will only pull the amount of power it needs. Manufacturers of PoE products should list the actual power draw of their device in their manuals or literature. Now, besides knowing the amount of draw that your devices will have, you'll also want to know your network switch's PoE budget. This tells you how much power is available in total. Let's say you're using a network switch capable of supplying Type 4 PoE. That's 100 watts to a single device. This does not necessarily mean the switch is capable of feeding 100 watts to every port on the switch at the same time. There are some that will do that sort of thing, but they are certainly a rare bird. Most switches will only feed the maximum power to a few ports, Or, of course, they could feed lesser amounts to a wide number of ports. Now, switch manufacturers will offer PoE budgets for practical and economic reasons. The more PoE you want to offer, the bigger your supply needs to be, the more heat that will generate. That generally means cooling fans and ambient noise. And all of that costs more money. So, if you have a situation where most of your devices are externally powered anyway, you might choose the more affordable switch that makes no ambient noise. In fact, if you look behind me here, I have a switch here that is perfectly quiet, and I don't mind having it here on the filming set with me. But if I was going to have a switch that is supplying significant power to a number of devices, all of a sudden that's a noisy switch, I would relegate that to an equipment closet. Now, regardless of how much power you're going to provide, you need to be able to figure out your draw and make sure it's within the PoE budget. Now, like most things, once we look at the PoE budget, we do not want to plan on using all of it. We'll want to keep some power in reserve. So why wouldn't we use all of the PoE budget? Well, first of all, there's going to be some power loss going across the cable. Devices will fluctuate how much power they draw over time. And just as a general engineering principle, you never want to use 100% of your budget. So you add all that up, and let's say a 20% buffer might be a good rule of thumb. So let's do a quick example. Let's suppose I have a network switch that will power a USB Avio adapter drawing about 3 watts, plus a pair of PoE speakers that will draw up to 25.5 watts each. I'll break out my notepad and add up the total draw of all 3 devices. That gives me 54 watts. Then if I add 20%, so that's 5.4 watts twice, that gives me 10.8 watts of extra capacity. And that means I'm looking for a switch with a PoE budget of at least 64.8 watts. So if my network switch provides at least 64.8 watts in its PoE budget, then I feel good running this system on that switch. If not, maybe I want to look for another model that will have a larger PoE budget. Not to be confused with PoE is EEE. Now this goes by several names: Energy Efficient Ethernet, Green Ethernet, 802.3az. In short, you'll want to disable this if possible. Energy Efficient Ethernet is designed to reduce energy consumption of the switch by turning off ports when they're not in use, or by reducing the power required. Unfortunately, when it goes through these experiments, it is known to cause data interruptions, which is problematic for any real-time network function. And we're not just talking Dante here. We're talking about any audio or video over IP protocol, including voice over IP phones and video conferencing. So it's best to turn off Green Ethernet. Now, if you forget to turn off Green Ethernet, or if you're on a switch where you simply can't do it, then the symptom to watch for is a rather random hiccup in clocking. Now, if you're commissioning a system and you find yourself working on one of those switches, that's not a reason for a work stoppage, right? It'll work the majority of the time and you can get your work done. Just flag that switch as something that should be swapped out in the near future. Okay, so the next thing to talk about is connections. We all know the RJ45 connector, but you may also find devices with this connection. It's called a Neutrik EtherCon. This looks like the shell of an XLR with an RJ45 in the middle, and that's exactly what it is. EtherCon connections are commonly found on devices that need to be quite rugged, for instance, devices that are going to be on tour. The EtherCon connector locks with the metal shield, and the EtherCon jack itself is typically screwed into the metal chassis of the device. If someone pulls on that pretty hard, you're not likely to damage your gear. By contrast, if you look at a typical RJ45 connection, especially those on network switches, the ports are often soldered directly to the circuit board. That and some simple clips are about all that's holding them on. So, if someone pulls on that cable, the printed circuit board is the only thing providing resistance, and damage is more likely if someone pulls on it too hard. But again, because there's an RJ45 in the middle, you can take your standard network cable, plug it in, and it'll work just fine. The EtherCon connection is about rugged durability. It has no impact on bandwidth whatsoever. And that brings us to cabling. Of course, Dante can use standard Ethernet cabling. For patch cords and structured cable, you should use Cat5e or better. They will deliver 1 gigabit speeds up to 100 megabits in length. Now, in shorthand, we still call these cables Cat5, but to be clear, you do not want to use a Cat5 cable. Those were only rated for 100 megabit speeds. You want Cat5e or better. Now, you can also use fiber optic cables with your Dante networks. There's no problem with that. People usually use fiber products because they want to exceed the 100-meter limit of category cable. Even the least expensive fiber optic products today typically start around a 300-meter reach and go up from there. Now, if you've never worked with fiber optics before, I assure you, most people make this out to be much more scary than it really is. But the main thing you need to know is that switches might have an open receptacle called an SFP slot. So why would the fiber transceivers be optional? Well, obviously, it makes the switch less expensive, especially if this is going to be in a position where you're not using fiber. Also, it allows you to install the fiber transceiver that you need. Certainly, a transceiver that will reach 300 meters is going to be less expensive than a transceiver that reaches 5 kilometers. And while this is beyond a level 1 concept, you will see switches that are almost exclusively SFP slots. Now, this is very handy if you have a switch that needs to accept a number of fiber connections. And interestingly, if you're on a switch like this that is entirely SFP, they also make transceivers that have an RJ45 connector on it. So now you could take a switch like this and build it out however you like. All right, so we know Dante can use a category cable in fiber optics. What Dante does not do is send audio or video streams across a Wi-Fi connection. However, we can send Dante control data over a Wi-Fi connection. Now, what that means is you can take your laptop, connect to the wireless network, and launch Dante Controller. You'll discover all the devices, you can make and break subscriptions, you can change your device and channel labels, right? Things like that. Now, if you have a Dante network and you need a wireless technology for some application, there's certainly plenty to choose from. Of course, we have wireless microphones and in-ear monitors that link to Dante. We have Bluetooth devices that make it easy to stream music or link a conference call into a conference room. There are professional links using 5 gigahertz connections to link channels across a performance space. There are Dante devices leading to transmitters for FM and IR, especially for museums, hospitality, entertainment, and assisted listening. So if you need a wireless device, there's certainly a wealth of Dante-enabled devices out there to choose from, and certainly one of them will fit your need. Okay, so we know about the hardware side with switches and cabling. Now let's talk network addressing. Operating a Dante network is as simple as running your home network. And here we'll go over some of the basics just to make sure you understand them clearly. When you have devices on a network, they will all have IP addresses. If one device wants to contact another, it's just like picking up the phone and calling a friend. Instead of dialing a phone number, we use their IP address. In this diagram, the laptop has an IP address of 192.168.0.101. Now, many of you intuitively know that it will communicate with devices on the local area network as long as they start with 192.168.0. something. We've learned this from our home network, but why is this so? Well, we'll get to that. But before I do, I want to come up with a very specific term. Right now, we're calling this the range of IP addresses that devices on my local area network should start with. Now that's a mouthful. How about we just call that a subnet? The subnet is the range of IP addresses found on your local network. Your device finds its subnet by using the subnet mask. Most home networks would have a subnet mask of 255.255.255.0. So you'll notice the first 3 fields of the subnet mask have a 255 in it. Okay, that means any device in my subnet will match my IP address in the first 3 fields. In the last field, we have a 0, and that means we ignore this field when defining our subnet. We can put any number in here, and that device will be considered to be on our local area network. So to put this simply, any device I'm trying to contact that is in my subnet, I will contact directly on my local network. If the device I'm trying to contact is not in my subnet, then I'm going to contact the router looking for help finding it somewhere else. Now, in your network settings, you'll also find a setting for the gateway. The gateway is the IP address of the router. So these are the settings you'll see on your computer. Now, of course, this screenshot is taken from a Windows machine, but the Mac OS screens are very similar. And of course, here is the screen in Dante Controller where we can set an IP address. The same settings are available. So, when we designate a subnet for our devices, there are ranges reserved for our use on a local network. I'm sure you're familiar with 192.168.anything. 10.anything is another common one. The third one's a little bit more complicated. It's 172.anything from 16 to 31.anything. So in our example from earlier, we could have just as easily used 10.156.217 as the subnet. That'll work too. As long as all your devices are in the same subnet, you're golden. The only admonishment I'd offer is to avoid the first and last IP address of your subnet. So if your subnet mask is 255.255.255.0, then avoid 0 and 255 in the last field. Okay, so we understand a bit about the mechanics of an IP address, so the next question is, how do we assign them in the first place? Just like a computer, you can statically assign addresses if you like, but we also support automatic addressing. Automatic IP addressing means a device will start by looking for a DHCP server. But what happens if there is no DHCP server to be found on the network, right? What if you've just taken your computer and a few Dante devices and plugged it into an unmanaged switch? Well, when it realizes there is no DHCP server, it will fall into a backup plan using Link Local. Link Local is a simple protocol. Devices will pick an address at random in the 169.254 subnet. Of course, it will pick a subnet mask to go with that. Notice this is 255.255.0.0. So that means any device in our subnet will begin with 169.254. Okay, perfect. So here's an example where I've set up devices on a network without DHCP. The devices that were set to automatic IP addressing reverted to Link Local, and they found an address in the 169.254 subnet. That's it. Now, just as a review, we can look at the screens in Dante Controller. Double-click on the device to open Device View. There, click on the Network Config tab. We see that devices will default to automatic IP addressing, but we can also select manual addresses if we want a static IP. Enter your information and click Apply. Some devices support the soft reboot function in this screen. Others may require a hard power cycle. And of course, don't forget that if you're seeing two sets of IP addresses for a device, this is showing you the options for the primary and secondary Dante ports. This means your device is set to redundant. Now, if you have a device set redundant and you only intend to run one, you don't have to go in and change this setting if you don't want to. The redundant port would just be left empty. It'll be okay. And with that, we wrap up another chapter. Dante uses standard network switches and cabling. No special hardware or firmware required. You can use your favorite brands with confidence. Dante can use managed or unmanaged switches. Small networks dedicated to Dante probably need no special considerations. An unmanaged switch may be just fine. When choosing a network switch, we strongly recommend sticking with 1 gigabit or faster switches. We talked about how Power over Ethernet works and why you'd want to disable Green Ethernet, or EEE. Dante can cross both category and fiber optic cabling. However, Dante media traffic will not cross Wi-Fi. Finally, Dante devices can join a network just like any other device you have. All devices on a common network should be in the same subnet, a common range of IP addresses. You can set IP addresses statically or allow the automatic addressing schemes to manage things for you. Automatic addressing will start with DHCP, and if there is no DHCP server found, then it will fail over to Link Local.